this is going to have, um, here we've got three systems that are all in with one another. If you look at them, they don't connect. It kind of looks like they do through components, but they don't connect through any components. This does not show the return path. But you have a left, a center, and a right system that are, roughly shown left, center, and right. And these each have various pumps. So like our left system has an engine driven and an AC motor pump, and our right system has an engine driven and an AC motor pump, and then our center system has AC motor pumps. Okay. Going to the various areas, and this shows the pressure side of it. Looking at a single portion in detail, you see something like this, and I was just kind of pointing out how are we on. Let's see. Are you able to see a single system now?
Yes.
Yeah. Okay. Uh, and we have, the fluid from the reservoir goes to our AC motor pump. It also supplies our engine-driven pump. And the engine-driven pump typically, in this case, would be the primary pump. AC motor pump would be a demand type pump where if the pressure in the system dropped, if the engine pump couldn't keep up, the AC motor pump would come on to supplement the flow of fluid. So it can be used on the ground, or when the aircraft's on electrical and the engine's out running, the AC motor pump can run the systems. When it's in flight or when the engines are running, it's used as a demand pump. And when you do the lab, you'll kind of operate, you'll have engines running at one point on the system simulator, and you'll do a couple different conditions and watch how the demand AC pumps react. Fluid that flows through these does come together though at the user. So when it comes out of the pump, you can see the engine pump fluid flow here, tees in with the AC motor pump from above and powers the various systems. In this case, they showed thrust reversers, brakes, primary flight control systems, etc. And so they do come together. And on their way there, they pass through items such as filters. There's different pressure sensors and that kind of thing. And then ultimately, the fluid flows back. The green line is our return side. And it's filtered again on its way back, and then ends up back at the reservoir. There's a couple other paths there we'll get to when we talk about pumps and that kind of thing. This should be another diagram that we saw earlier in the slide deck. Three systems with a line diagram.
It still says hydraulic system makeup.
But is it a new picture?
That's
No.
the picture.
That same picture. Are the annotations coming through when I draw on them?
No.
Yeah.
Oh,
Are you talking about like the red arrows?
My arrows and stuff like that, yeah.
Yeah, the arrows are still on there.
But it's still
Oh, there it
delayed.
is.
Now it's here.
Okay, now we got our hydraulic system makeup. So here's, again, three systems, very similar. The reason I'm showing several is I just want to show, the architecture is similar, right? We saw a second ago was the 737 next gen. Now we're looking at an Embraer 175, and again with three systems. Our two main systems, 1 and 2, each have an engine-driven pump. They each have an electrically driven pump. And then the system 3 here also has two electrically driven pumps. Now, one of those would be the primary pump, and the other one would be that secondary, that demand-based pump. And then those still go through a filter manifold. They still go through filters. And then they go out to the various systems. Now, this doesn't show the return path, but the makeup whether, no matter who the manufacturer of the aircraft is, whether it's a Boeing or an Airbus or an Embraer or a Bombardier or Mitsubishi, these hydraulic systems aren't particularly unique from aircraft to aircraft. They all have a pretty much the same general layout. So if you start to understand like what makes up the hydraulic system, these closed center hydraulic systems, no matter what aircraft you look at, you should be able to look at one of these schematics and be able to figure out kind of an idea of what's going on. One component that this one has that wasn't on the 737 is it does have a power transfer unit at the bottom. And what that does is it allows pressure from the number one system to operate something called a hydraulic motor. It basically spins a motor that then spins a pump to provide pressure to the number two system. But it doesn't allow the fluid from the two systems to intermix. There's no fluid passage there. It's fluid powers a mechanical device, powers a pump, so it creates mechanical rotation. And that mechanical rotation powers a pump that sends fluid pressure into a different system. When we do the lab on the 727, we'll open something called an interconnect valve between two of the systems, and that's going to be one of the last airplanes built that had that. The downside to an interconnect valve is that is a valve that allows fluid from system B, the B system, to flow into the A. And so your risk there is if you have a leak in the A system, you can drain, you don't want to drain the B system through the A or the A system through the B system. The other thing is if a hydraulic system gets contaminated, now you would contaminate every system on the airplane. And so they've gone away from, aircraft have gone away from using the interconnect valve and gone to these power transfer units. And I know they have them on the Airbus. Airbus uses them quite extensively. Boeing uses them. Embraer uses them. So it's a common feature to allow one hydraulic system to power another. Should show another makeup.
No.
Hasn't moved yet.
Yeah. Give me a stick, maybe I'll swap out.
Yep, there you go.
There it goes. So you can see this is kind of an older diagram, but if you look at it, it's very similar to our other ones. They have a left, a center, and a right. Electric and engine pump on each one. This is off of an Airbus. So again, just the point of all these diagrams that are very similar is just to show that they are all very similar, that the systems all work in a very similar manner no matter who built your airplane. And this one, again, has left and two of the main systems are engine pump and electric pump, and then electric pumps for the third system. So this one has a power transfer unit as well to allow the right system to power the left, or more specifically, it allows the right system to power the left system, like the stab trim, stabilizer trim, because that's so important, which is more technically part of the left system. So we're going to move from the system makeups to the actual component level, what the components are.